Thank you. I have the pleasure today of hosting this session to draw attention to the importance of northern peatlands, with a special focus on northern Canada, and in particular, the Hudson Bay Lowland in northern Ontario, Canada, which is the second largest peatland in the world. So I first just want to acknowledge that I'm talking to you today from the traditional territory of Fort William First Nation, signatory to the Robinson Superior Treaty. And I want to thank the Global Peatlands Initiative for organizing this session and giving us this opportunity to talk to you today about the importance of northern peatlands. So we're all here at the Peatlands Pavilion to draw attention to the disproportionate role played by peatlands in addressing the climate emergency. But when it comes to peatlands in the world, there's a great deal of attention on tropical peatlands and peatlands in Europe that have already been extensively converted and require restoration. But in Canada, we still have extensive and intact peatlands, and the essential carbon services that these peatlands are providing right now are under threat. So both from climate change itself and also from natural resource development. So protecting and maintaining northern peatland ecosystems are essential to meeting national and global climate targets, but right now we don't have adequate safeguards for these systems. So over this next 90 minutes, I'll be joined by 3 experts on peatlands and the Hudson Bay Lowland. And together, I hope that we can all help you gain an appreciation for northern peatlands and an understanding of the path forward that we need to take in order to keep benefiting from the critically important role these peatlands are playing in global climate regulation. So my name is Connie O'Connor, and I'm the director of the Ontario Northern Boreal Program with Wildlife Conservation Society Canada, and I'll serve as the moderator for this session. But joining me are 3 experts on peatlands in the Hudson Bay Lowland. So I'm very honored to introduce Lorna Harris, Justina Ray, and Vern Chichu. So Dr. Lorna Harris is a peatland scientist currently at the University of Alberta, and she has dedicated her career to studying northern peatlands, first in the United Kingdom, but for the past decade in northern Canada. Dr. Justina Ray is the president and senior scientist of Wildlife Conservation Society Canada, and she has expertise in research and policy related to conservation-based planning, environmental assessment, biodiversity conservation, and she's also been appointed to numerous government advisory panels in Ontario and Canada. And then Vern Chichu is the director of lands and resources for Mushkegowuk Council, which represents 7 First Nations whose homelands are at the heart of the Hudson Bay Lowland. So the format of this session is that I'll just do a quick broad overview of the incredible ecosystems that are northern peatlands. Lorna will then explain the critical importance of northern peatlands for the global climate regulation, including recent findings from a scientific paper that she's just publishing on the important role of northern peatlands. Justina will then shift into discussing the policy implications of this work, where our current policy frameworks fail to address the critical role that northern peatlands play, and what policy frameworks are needed. And then Vern will talk about the importance of these peatlands as a homeland and the imperative for Indigenous-led approaches to peatland protection and conservation. So we'll wrap up the session with time for questions and a panel discussion. So if you do have any questions during the talk, put them in the Q&A, and then the panel can address these comments during the discussion segment at the end. So just to launch into the quick sort of overview of what we're going to be talking about today, addressing the climate emergency is often understood from the perspective of reducing emissions. So reducing the burning of fossil fuels, reducing emissions from transportation and buildings. But in the background is the ongoing work of the land and the water, which together are absorbing about 50% of the carbon that we humans are emitting. And our path to net zero assumes that both the ocean and the land will continue to absorb about 50% of annual emissions. But we can't just take this for granted. Without dedicated protections and safeguards, the land and the water won't continue to be providing this vital role. So in this map, the undegraded forests are the dark green, and they hold much of the carbon that is doing this natural role of cooling the planet. But they're retreating fast at a global scale. So Canada has an enormous global responsibility to protect these forests, but embedded within these boreal forest regions are peatlands. 32% of the global peatlands are in North America, 25% of these are in Canada. They cover about 12% of Canada's total land area. And the largest of these is the Hudson Bay Lowland. So the Hudson Bay Lowland, spanning the southern edge of Hudson Bay between Manitoba and Quebec, is the 2nd largest peatland in the world. So for the UK audience, this peatland itself is the size of the United Kingdom and Ireland combined. And this peatland is not just absorbing and storing carbon and cooling the planet, but these peatlands are also a homeland, the home of Anishinaabe and Cree for millennia. So Vern will tell this story later in the session. But I'll also add that these peatlands are also important for biodiversity. And so this is my connection, because I'm actually a fish scientist in a peatland session. But within the Hudson Bay Lowland, within this peatland, there's also free flowing rivers that are the home to lake sturgeon, sea rum brook trout. It shelters rare plants and lichens. These intact areas are also a refuge for iconic northern wildlife that has declined in other areas that are more developed. Animals like wolverine, caribou, wolves, moose, and polar bears. And this area is also important as a breeding ground for countless bird species. There are millions and millions of birds that come to the Hudson Bay Lowland to breed each short summer. So this area is, it's not just carbon, but it's beautiful. It's essential for humans and wildlife. But of course, this session is about carbon and climate change. So now I'll hand it over to Lorna, who will get into the science of the carbon and the land itself for climate change and for people.
Okay, thank you, Connie. Just to acknowledge before I begin that I am speaking to you all from Edmonton in Alberta. This is Treaty 6 territory, the homelands of Cree, Blackfoot, Métis, Dene, Nakota Sioux, and many others. And then firstly, going back out to the global scale, which Connie has already showed, just to highlight just the enormous quantity of peatlands that are in Canada. Canada has 1/4 of the world's northern peatlands. It's around 1.1 million square kilometers. This is 27% of the global peatland area. So this area is absolutely enormous, and you can see this very clearly on any global map of peatlands. Next slide. So the importance of peatlands in Canada cannot be overstated. They are the world's largest peatland carbon stock, storing around 150 gigatons of carbon. This is 28% of the global peatland carbon stock. And you can see from the map here that they span the entire country, from the Northwest Territories, Northern Alberta, through Saskatchewan, Manitoba, and you can see the huge quantity of peat there in Northern Ontario. This is the Hudson Bay Lowlands, which we will talk about more today. Next slide. So the Hudson Bay Lowlands, this area, as Connie has already mentioned, is big, bigger than the UK and Ireland combined, and it is almost continuous peatland. It is 80 to 90% peatland, all different bogs and fens, water tracks, and all different free-running rivers across this landscape. It's also a huge carbon store. It stores around 30 gigatons of carbon. This could be a lot more. This is more than the entire managed forest across all of Canada. So this is a huge quantity of carbon in a dense space. Next slide. So this graphic illustrates the difference in the quantities of carbon stored, comparing tropical forests, boreal forests, and boreal peatland. So you can see that it does depend on the soil types and the setting, but generally for tropical forests and boreal forests, the carbon stored within those soils is less, and it's also only stored for a few hundred years. The turnover of this soil carbon is much faster than in northern peatland ecosystems, such as boreal peatlands. And here this carbon, the quantities of carbon are much greater. This carbon is also stored for thousands of years. So this is carbon that was taken from the atmosphere thousands of years ago. It's been stored there in the soil. It's not very easily decomposed. So the turnover is very slow. And we need it to really remain in the ground here. Because if we release this carbon stored in these systems from thousands of years ago, that's just going to undermine our efforts to restore peatlands, to reduce greenhouse gas emissions, and to limit global climate warming. Next slide. So peatlands across Canada provide an essential global carbon service. And if undisturbed, most of these northern peatlands will remain a persistent carbon sink in most future climate change scenarios. So it's only in the very worst climate change scenarios that we start to see an effect on these peatlands, a negative effect on the carbon stores. There are also differences across Canada, particularly east and west, in the response of peatlands to climate warming. So in Western Canada, climate models predict a warmer and a drier climate, and this is expected to reduce the size of the peatland carbon sink for peatlands here. In Eastern Canada, it's a slightly different story. The climate models predict a warmer and wetter climate. So here we may actually see increased plant productivity and increased plant peat accumulation. So we may actually see these peatland carbon stores become much bigger sinks with a warming climate. Next slide. So the response of different types of peatlands across Canada also varies to predicted global climate warming. And although scientists are out collecting data on all of these different types of peatlands, we do have limited data, and especially for some of our larger peatland regions, we only have like a few sites within some really vast landscapes. So I'm highlighting here some of the different peatlands we have. There's a sphagnum and spruce bog in the Hudson Bay Lowland. This bog is adjacent to a patterned sedge and tamarack fen, a groundwater fed fen. We also have on the bottom left there, a sedge fen in a Thawing permafrost landscape in northern Alberta. And then some of the least studied peatlands we have are these mixed wood peat swamps, with this example here in southern Ontario. Next slide. So we also have limited data on winter emissions from these peatlands. And this is mainly because not everybody wants to trek out to a peatland through a meter of snow and -20 Celsius weather to go and measure greenhouse gas fluxes. But there's also because we just assume because the peatlands are frozen for the winter that there are no emissions. However, our climate is changing and we are seeing changes in precipitation. We're seeing more snow cover in some regions, less snow cover in other regions. And we are seeing some warmer periods in winter, which are causing these early thaw events. So where there's significantly reduced snow cover and there's actually warming of the soil. So here we probably are seeing some emissions. So this photograph on the right is showing an example that we have here in northern Alberta. Have some sensors, automated sensors that are measuring soil respiration from a permafrost peatland. And we're going to keep them going over this coming winter, hopefully to also capture those thaw events in late winter and early spring as well. Next slide. So these vast landscapes, the hydrology and the ecology of them is also intricately connected. And also the carbon cycling across these landscapes is connected as well. So this photograph here is an example from the Hudson Bay Lowland. You can see a raised bog, and on either side there's a water track on the right-hand side there, and on the left there's a big patterned fen. And the arrows show the general flow paths for water flow within this landscape. And here, all of those flow paths are headed towards the Attawapscat River, which will eventually lead into James Bay. So here, this is why there's these vast landscapes. We have to consider landscape hydrology. And it's why we also need to be mindful of the effects of any disturbances on these upstream peatlands on downstream ecosystems. Next slide. So we discuss more detail on these science gaps and research gaps in a paper that is due to be published in the next week, coming out in Frontiers in Ecology and Environment. Here we focus on the issue of irrecoverable carbon. We highlight the threats to northern peatlands in Canada and the impact on irrecoverable carbon. We also discuss gaps in policies and also in greenhouse gas reporting. And I'm going to go into a bit more detail on that in a moment. Next slide. So irrecoverable carbon was covered in a paper by Goldstein in 2020. Irrecoverable carbon is essentially a peatland carbon stock that, once lost through land conversion, is not recoverable in the next 30 years, so not in time to meet net zero emissions by 2050. And this paper highlights tropical peatlands as especially vulnerable to the loss of irrecoverable carbon. But perhaps here for boreal peatlands, we think the threat to these peatlands is a little bit underestimated. And I'm going to explain why in the next few slides. Next slide. So as I mentioned earlier, in Western Canada, we're expecting to see a warmer and drier climate. And this will increase wildfire risk in peatlands, which will become drier here. So in these peatlands, fire causes a large loss of carbon in the above ground biomass, but also in below ground in the peat soils. This is an immediate loss at the time of burn, but it also continues to be vulnerable through peat smouldering and increased decomposition after the fire. So this carbon is irrecoverable, and next slide. And this is because post-fire vegetation recovery in these systems is very slow. So it could be 5 to 10 years before we see moss recovery. It could be a lot longer for sphagnum moss to recover, particularly if the peatland is quite dry. And to regain shrubs and trees, you can see a very tiny spruce sapling in that photograph there, that's like 2 centimeters tall. It takes a long time for these systems to recover. And another recent paper that just came out highlights the impact of an increased frequency of fires on vegetation recovery in these systems. So really, that places more emphasis on the loss of the irrecoverable carbon. We just don't get it back within 30 years. Next slide. We also have a large extent of permafrost across northern Canada, and this map is showing permafrost peatlands across Canada. And a few studies have shown recently that most of these sites, many of these sites, will likely turn into a carbon source over the next 100 years due to permafrost thaw. These systems, the ecology, the hydrology, when permafrost thaw occurs, you see huge changes in the types of ecosystems across these landscapes. And we don't fully understand the consequences for carbon cycling within these landscapes. So the scale of that carbon loss is not easily understood here. We also don't really know the fate of this carbon because it really does depend on our actions today to reduce greenhouse gas emissions. There is still a possibility to keep some of this carbon in permafrost in these northern ecosystems, keeping that in the ground in a frozen landscape. Next slide. But where thaw does occur, we do see large losses of carbon. So this figure on the left is from a data set I've been working on from a thawing permafrost landscape in the Northwest Territories. And we are seeing large losses of carbon from these thawing ecosystems. And this carbon also is not recoverable. This is because peat takes a very long time to accumulate. So even if we have very rapid peat accumulation at the surface, not all of this is added to the long-term peat carbon store. So this takes a very long time to build up those peat carbon stocks that have been lost. And these shifts in ecosystem that we see are taking place over centuries as well. So this is something very important that we need to track with climate change. Next slide. So there are some peat disturbances where we do know the exact area impacted, and we do know the greenhouse gas emissions from them. So this example is peat extraction for horticulture. We know that for Canada, around 350 square kilometers has been impacted, and we know around 1.6 megatons of carbon has been lost here. But this is only one of the few examples that's actually included in national greenhouse gas reporting. There's this one, and there's flooding for hydroelectricity. Other disturbances are not included in national greenhouse gas reporting. Next slide. This includes peat removal for open pit mining and the impact of drainage from the mining, from the road development and other infrastructure within these regions. The area impacted here, the greenhouse gas emissions are not included in Canada's greenhouse gas reporting. Similarly for seismic lines for oil and gas exploration, there are huge areas there as well that are not included. And all of these disturbances are causing a loss of irrecoverable carbon. So it's important to track these. Next slide. So I'm going to go back to the Hudson Bay Lowlands here, just to highlight again the scale of this landscape. It covers over 370,000 square kilometers, around 30 gigatons of carbon, but could be more. We have limited data for this region. It is quite difficult to access a lot of the sites. Mostly it's by helicopter, which is obviously very expensive. So in terms of a carbon store, it really is one of the world's largest peatland carbon stores. It's the second largest. It's also a critical area for freshwater and for biodiversity as well. And these peatlands, as I've mentioned earlier, with the predicted climate warming in the eastern Canada, in this region in particular, it's likely that this could become a larger carbon sink. So with warmer and wetter conditions, this area will continue removing carbon from the atmosphere, continue storing all of that carbon from thousands of years ago, and could actually increase how much carbon it removes over time. So next slide. But this will only happen if these peatlands are left undisturbed. And unfortunately, this region is also an area with significant mineral deposits, particularly critical minerals. There are significant deposits here. And I'm highlighting just one deposit, one area of development. It's called the Ring of Fire. You can see it highlighted in the circle, the yellow circle there. This area is over 2,000 square kilometers of mining claims. And this area is all completely overlain by near continuous peatland, and possibly also some of the deepest and most carbon-rich peatland in the Hudson Bay Lowlands. So if this development was to go ahead, there will be large losses of peat carbon. We estimate this could be between 130 megatons of carbon up to 250 megatons of carbon. There's some uncertainty there just because we don't know for sure how much peat is there, how much peat carbon is there, and we don't know the full impacts. This is equivalent, I think, to over 1.3 million cars over their lifetime. So this could be quite a large impact. Also noting that the development is in the headwaters of many large rivers, particularly the Attawapiskat River here. So there will be impacts from this development. And I know Justina is going to talk a lot more on this, so I'm going to pass over to her now.
Great, thank you, Lorna. So I'm talking to you from Toronto, or Takaranto, which has for thousands of years been the homelands, the traditional areas of the Huron-Wendat, the Seneca, the Mississaugas of the New Credit, and many other Indigenous peoples today it is home to. And I'm going to also be focusing on this policy brief that we just released today. Smart Prosperity Institute, and particular Paige Olmsted was the lead writer of this. And we worked on this together using the Lorna Harris's manuscript with all our colleagues as the basis for the recommendations that we have in this briefing. So what I'll be talking about today is sort of in three parts. First is to provide a bit of context. And we've heard about the consequences of conversion of northern peatlands of many sorts, and now I'll focus on that, the essential changes. But first, the policy context a bit, then the gaps that exist today, and then going into solutions to a certain extent. I'm focusing, next slide, mostly on the global and national scales. I mean, global is really where the biggest focus of the Global Peatland initiative and the pavilion, in terms of really focusing on this consistently difficult, the challenge of the undervaluation of peatlands. The more we understand about peatlands, the more we understand also how little it is being valued. It is not being directly considered in frameworks that we've constructed. And a lot of that is because of our growing knowledge, of course. But as we understand it, then it becomes more and more imperative for us to bring that in. Next slide. Most of our policy solutions that are in this brief really focus on the national scale. They have global implications, particularly for a country like Canada that is the second largest in the world. But they go back and forth, because a lot of this has to do with our reporting globally and our responsibility, our disproportionate responsibility as well. And so the types of policies that I'm looking at range from everything from carbon accounting and reporting, and how we report to the UNFCCC, and how we account for emissions in various processes and so forth, but also development planning, and particularly impact assessment, which is our most common tool for project level impact, for project level planning, increasingly strategic and regional planning as well. I'll talk also about data collection and transparency, because that underlies a lot of the challenges that we have with respect to policy development. And then finally, protection and conservation. So this is a story really about making a case for long-term management of carbon. It's very different from how we mostly do business, which is sort of waiting until there's an immediate quantifiable threat, and then dealing with the consequences accordingly. This kind of problem that we've been talking about, that Lorna just described, in terms of the implications and the consequences of not taking care and safeguarding our peatlands proactively, is one of foresight and advanced planning, and that's central to the final part of the story, which is about Indigenous stewardship. Next slide. So a part of the context of policy context is really understanding that Canada has disproportionate global responsibility, both for positive and negative emissions. The Carbon Brief just came out with this graph the other day, which is no surprise to many of us, about sort of ranking cumulative carbon emissions per capita of a number of countries, with Canada out on top of per capita over the last 170 plus years. And this is a consequence of, in spite of our very small population per unit area, we've had that disproportionate impact, and that's called positive emissions, which was perhaps a misnomer. The next slide. We also have this extraordinary responsibility, as we've just been hearing about, for more the intact global land sink, that a lot of which lies in Canada. So we haven't, in spite of our large emissions record, we have not developed so much of the area that still is in Canada. Many of these are all Indigenous homelands, but also these are areas where we have great resource interests, but have not gotten there yet. So there's another sort of signifier of our global responsibility. Next slide. And this one, we focus specifically on peatlands, and the story, which we haven't shown this map yet, but a lot of these peatlands really still lie, the largest proportions of this, in as yet unroaded intact areas. So these are outside areas that have either been converted by human settlement, and that red line there shows where over 70% of the population of Canada is concentrated in the very, very southern parts of the country. But our resource management footprint is exemplified by the black, which really extends way further north. And this is because natural resources are a big driver of our economy, have been since the very beginning of the settler economies. And this is just really very clear, particularly in the Western Sedimentary Basin, where there's been so much oil and gas exploitation. But there we are talking about the intact peatlands and how to safeguard that so that it doesn't meet the same fate as much of the rest of the country. Next slide. And Lorna has already mentioned this, but just quietly, minerals have become a very important share of our total resource wealth. And this is just something that came out from Statistics Canada a couple of days ago that looked at 2020, and there's really where minerals have overtaken oil and gas and timber in this regard. And this is part of the conversation is about critical minerals. So-called critical minerals are going to be very, very important for the clean energy transition. And, this is a quote from a report that just came out by the International Energy Agency just a few days ago as well, or just recently as well. We're really looking and paying attention as to how important these critical minerals are going to be for development in the future. And many have their eye on it. In fact, Canada is a key source for 13 of the 35 minerals that the US has identified as critical to its economic and national security. Next slide. And why does that matter? Because a lot of these places are going to be in these currently intact boreal peatlands. This is just one depiction of advanced projects in blue of various minerals which are coming into these areas increasingly. Certainly they are of great interest. And a lot of these don't see the light until they're really advanced in their interest. But these are going to be furnishing critical minerals for among other things, the transition to the clean economy and clean energy economy that we're all talking about in the context of the net zero goals. Next slide. So having laid out the context, what are the policy gaps that we're most concerned about? Lorna talked about these to a certain extent, and most particularly the fact that a lot of the human-caused emissions that come from particular types of development are not at all counted for in our national inventory reports. And that's a lot to do with the lack of science and models and emphasis on these kinds of types of projects. And they range from mining to seismic lines to other road development and so forth. That when we have a very good idea about sort of above consequences to above ground biomass removal, but not so much about soil carbon disturbance, hydrology, and so forth. And that's really where our biggest weakness is. Next slide. We're also not accounting for so-called natural disturbances, and there's a reason for that. I mean, these are not by definition those that we are human caused that we mitigate, but we are indirectly responsible for these, of course. And the best way, the way that we have been accounting for this is to divide the geography between managed and unmanaged lands. And this is one mechanism for us to be able to sort of circumscribe the carbon emissions that we account for. But overall, from a peatlands perspective, as we just saw from the combined forces of permafrost melting to fire and so forth, there are significant emissions that are happening all the time that we're not figuring into our budgeting for carbon to decision making and so forth, which is really important and cannot be ignored. Next slide. We have very far-reaching and by some measures significant climate plans at the federal scale, and nature climate solutions are becoming increasingly part of the discourse and recognized as part of the solution. But peatlands are not yet in the conversation to any significant degree. In fact, the only place where they really tend to be mentioned is with a focus on restoration and not so much this proactive conservation angle that I've been talking about. On Saturday, our new environment minister did announce some new investments that have been part of a recent election campaign that include nature-based solutions to climate change, which was very, very welcome. Next slide. But we can't really talk about that without talking at the same time about all of the financial support that's being brought to bear in terms of providing financial incentives for activities that lead to the conversion of peatlands. So these things counterbalance each other, and in some jurisdictions, the financial incentives for conversion far outweigh those that we're using for incentivizing their protection. So what am I talking about? I'm talking about things like tax credits and incentives for mineral exploration. You know, these are very, very remote areas, and junior companies do require these legs up in terms of being able to get into these areas and look and see what the economic opportunities are. But the fact remains that once those opportunities unveil themselves, they become very baked in. And it's very difficult to then have a mature and sort of the scale appropriate conversation about what the consequences might be to full scale mining, particularly when new areas are open to development. Another type of incentive is about provinces in particular that finance road development in order to access some of these remote areas. And that's happening right now in the Ring of Fire, where there's active planning for a road that would extend 300 kilometers or so from the provincial highway system into the Ring of Fire mineral deposits. And that is being entirely financed by the provincial government of Ontario. Next slide. The other policy gaps is just our tendency that to really, when we rely on impact assessment, is the project level impact assessment, which is at the top of this pyramid, which really, when projects get baked in, when projects become much more sure, when alternatives have kind of been eliminated, when you're really carrying out an approach that's going to force you into sort of a reductionist notion of what the consequences are from an impact perspective. What many are advocating increasingly everywhere based on decades of experience with impact assessment, both in Canada and elsewhere, is to go increasingly to the larger strategic and regional levels, because that's where you can more understand the larger picture of impacts and particularly as a cumulative nature. The gap at present is that most of our impact assessment processes are really way too limited for this picture, because they're really focused at this very, very small project level. Next slide. And, there must be something to be said when we're talking about policy gaps. I mean, the carbon offsets are really very significantly are often talked about in terms of in tandem with nature climate solutions. And they are most appropriate when you've got definable projects with quantifiable emissions that you get to at the end of this so-called mitigation hierarchy, which is depicted here on the left. And so you've gone through the exercise of trying to avoid and reduce and substitute and sequester carbon, and this is your the last step in the hierarchy where you're going to offset these emissions. Really, where we want to be in this conversation is at the first step with avoided conversion. And it also, because so much of these decisions are made with respect to quantifiable projects that don't deal with soil carbon and so forth, most of the time the conversation is very inappropriate for these larger intact peatland landscapes. Next slide. On to the policy solutions for my last few minutes. They really come in 4 buckets. First, and fundamentally, is increased investment in science and information. And before you say, well, that's what all scientists say, it is because these are such large intact areas where soil depth measurements are not captured by remote sensing, because where we still have such huge information gaps with respect to fluxes and so forth. And then that is stopping us from having the best models possible and quantifying the fluxes in this fashion. We also need a national inventory and so on. But this is fundamental, which will require an investment in very remote places in tandem with Indigenous community research consortia. These are, by their very nature, expensive but necessary. Next slide. And in tandem with that, we are advocating to include all relevant carbon fluxes in the national inventory and carbon budget. Even if Canada is not going to be responsible for all of them from a mitigation perspective, tracking them is absolutely critical to get a full picture of carbon flux to inform carbon budgeting in Canada and globally, because Canada has such an enormous contribution. This has to be fundamental to improved NDCs, which is starting. There have been some sessions in the Peatlands Pavilion with other countries looking at peatland, the role of peatlands and NDCs, and we hope to see that more and more in Canada as well. Next slide. We also have to pay particular attention to the sort of whole notion of development planning, which happens mostly in impact assessment processes. And this has to happen in a number of ways. On the right-hand side, we've got sort of an open pit mine example where that has required the removal of not only a larger area of peatland, but also the enormous depth. What are the consequences to that? How does that figure into the decision-making? Not just from a mitigation perspective, but also from an avoidance perspective. There's much we can do at the project level, but there's even more we can do at the regional scale. This graphic on the left is meant to depict the so-called growth-inducing impacts of just a road that come in for the purposes of opening up a region. And rarely do we have any conversation from a project level impact assessment perspective about what are going to be those consequences, what are the various scenarios of change that are going to develop after this in terms of both consequences to GHG emissions and so forth. We know very well, for example, that the roads that is being developed now in 3 pieces to the Ring of Fire is going to likely have growth-inducing impacts. So cumulative impacts and lead to more projects. We need to be thinking about that at the outset and considering alternatives very carefully early on. Next slide. And finally, the incentivization and prioritization of protection, this long-term carbon management, the proactive. It doesn't mean everything's a protected area. Right now, only about 10% of those northern peatlands have any sort of on-the-ground legal protection. That does need to increase, but more importantly, we need holistic measures that talk about that really are able to manage the pace and scale of development at the same time as protecting the carbon source for the essential services that they provide. This will require attention to lots of enabling mechanisms. We need entirely new financial incentives that are not reliant on offsets mechanisms. We also need to be having conversations about carbon tenure, and that's particularly important from the foundation of Indigenous protected and conserved areas. Next slide. And lastly, to tee up Vern Chichu, I just want to say that there are lots of examples of proposals for Indigenous protected and conserved areas that fall right in the peatlands, as you can see from all these dots. Most of them are emerging, meaning they're at the more towards the beginning conversation, but all of them carry visions from the Indigenous leaders who are promoting these protected areas and at various scales. And so this will have to be a mechanism, and the stewardship and the guardians that go along with that for the future. And I'll end with that and hand it over to my colleague Vern Chichu for the last words in the session.
Thank you very much. Thank you, Justina. And thank you, Connie and Lorna, for the presentations that you've made. I am happy to be here, glad to participate. And an Askamon, Ewachem Yak Maswet, Dutemic. I'm doing my greetings in the Cree language, the language of my people, saying hello to my friends and relatives. When I say relatives, we are connected when you look at the waters all around us. We are all connected by that water and that environment. It connects everyone throughout the world. My spirit name is Waswanakwit, which means yellow cloud, and I am part of the Eagle Clan. And I'm speaking to you today from Timmins, Ontario, which is about an hour flight south from the James Bay region where I come from. And there's no snow. It's November 8th, and it's 12 degrees above, which is unusual. For this time of the year in this region, we usually have snow. Those, just points to the changes that are taking place throughout our world. The Mushkegowuk territory spans approximately a third of Ontario within the northeastern region of Ontario, from the James Hudson Bay region all the way south towards the Great Lakes of Ontario. We represent 7 communities within our territory, and 4 of which are nestled along the western James Bay coast. And these communities are situated anywhere from 10 to 15 miles from the mouth of the James Bay. There are 2 other First Nations along the Hudson Bay western coastline, Winnisk First Nation and Fort Severn First Nations, that we work with. And they are not part of our tribal council, but we still work with them as they are Mushkegowuk people as well. And today I want to talk about our relationship to the land and waters of this region. Our relationship is very important to us. Our relationship to the environment, to the animals, to the water life, etc. It's very important, as it's our connection to the land. And we say, we are the land, we are the waters, we are the animals, we are the environment. And therefore, whatever we do to the land and territory, we are doing to ourselves. And we're seeing that happen, and there's been many attempts over the years to remove us from the land and remove that connection from us. We've heard about and experienced the residential school system that was implemented in the 1800s to take us from our lands, put us in schools, and rid our language from us. You know, people were basically tortured, you know, and strapped and things like that for speaking their language. If they were caught speaking their language, that's what would happen. So those kinds of things were attempts at removing our connection to the land. They took our traditional tools that we use for our ceremonies, the drums, the pipes, and all those tools that we used in honoring our connection to the land, to the universe, to our creator. They all played a role in how we managed and stewarded the land that we lived on. And that was taken from us. And we've spent the last many years, you know, regaining our language, our culture, and our tools to continue to do our responsibility in terms of maintaining that connection with our land and the environment. And I believe that's what we all have to do, is we have to reconcile our relationship with the land, because we've severed that connection. We've severed it in ways in which it's impacting on our regions, our life. It's impacting and could be detrimental down the road for all of us, not just us, but the whole world. And that's what we're seeing. We live in a unique part of the world, a unique region that you've heard is said to be the largest wetlands in North America, housing the 2nd largest carbon sink in the world. 5 of the Mushkegowuk communities live in this region along the western James and Hudson Bay coast. It is also said that if the northern boreal forest region is the king of carbon, then its crown jewel is the Hudson James Bay Lowlands, because of what it does. So since time immemorial, we have lived as we have always lived, taking from the land and waters that provide us this food and fresh water that sustained our people for a millennia. We respect our relationship with the lands and waters and understand that we are part of the cycle of life and we are not superior to it. I, as a little boy, grew up on an island on the Moose River, about 15 miles from the mouth of the southern tip of James Bay. Moose Factory is known as the oldest community in Canada, more than 350 years old since the establishment of the Hudson Bay Post and Hudson Bay Company. And the fur trade came into our region. We are also known as the people of the Bay, the Winnipeg we call it, and Wasebia, which is the Hudson Bay. The land is rich with wildlife and many kinds, both on land and in the waters. Research shows that this region is a very important habitat and staging area for about 400 different species of birds. As you heard in the early presentations, there's many, many types of birds that come to this region. It's a very important staging area. And in the fall, when migration begins, there are approximately 3 to 5 billion birds leaving this region, heading south for the winter months before they return in the spring. Fall and spring are very productive times of the year for goose hunting for our people. Goose is one of our main staples of food. Summertime is for fishing, and winter is trapping within our territories. As a young boy, I remember my dad, taking me hunting, in the fall, when the goose season would be there, the fall when the geese are beginning to migrate south, they stop in this region in the southern tip of James Bay. And when we go out there, we would see tens of thousands of what we call the wavies, the blue goose, and snow geese. And these are the geese that we would hunt in the fall. It was a very exciting time of the year for everybody. And most of what we invest in food gathering is at these important times of the year. Like I mentioned, we followed the cycle of life. I remember in late fall, during the frost season, late October, we used to hunt partridges before we went to school. So we would get up, at 5 in the morning, and wait for daybreak, and I was like somewhere about 7, 8 years old, and by that time, my dad had taught me how to use a gun, and the safety cautions and things like that. And so a lot of us young boys before school, we'd go out there just in you could say our backyard, just off from the community. We'd see partridges sitting on these trees and that we would, go and get before we went to school. So we would, once we got the partridges, bring them home, and then my mom would prepare them, for either lunch or supper that day. And during the early fall and late spring seasons, we would go down to the shoreline of our island and set our hooks for fish. And we used to, a lot of us kids, were down there. We spent a lot of time out on the land as children because we were taught that, we were already shown that. So we would go down there and fish, and same thing, bring our fish home when we caught fish, to be prepared for supper or else the next day's meal. So we were always gathering food, whether we were young boys or, young kids or older, when our parents were out there hunting and gathering food. But, we started to notice changes to the region. On the island where I lived, there's no more partridge. We don't have that anymore. There's no more fishing along, the shoreline of our islands. The fish have moved elsewhere. The rivers have been dammed, and the sediment that's coming down, that's settling in those regions, because in our region, it's a delta system. And there's always changing, the sandbars and different things like that. That's killing the habitat of the fish. And so the fish have moved to other areas, and we have to travel further to gather, those fish, right? Set our nets and that. So you have to get a boat and motor, to travel, and so those kinds of impacts, we've seen. And then in the southern part of James Bay, where we used to go and see tens of thousands of geese in the fall, and there's no more geese during the fall season. They started to disappear. It's been ongoing now for the last 30 years. The other, things that we're seeing is that we're experiencing more winter rains. There's early thaw. This impacts on the flyways of the geese we used to hunt. Now those geese don't fly in our region anymore. They fly further north and further west from us. So we don't get that, it impacts on our food security because we don't have that anymore in our region. The only time we hunt now is geese is in the spring, and those are the Canada geese. The Canada geese are the ones that we would hunt in the spring, and the blue geese and the wavies, the ducks, and that we would hunt in the fall season. So that part is gone for us. And it's not natural, to go out in the fall and there is no sound of the tens of thousands of geese that we used to hear that were once there. There's no sound. It's very eerie, and quiet, when it used to be quite a busy happening place, where people went to gather their food in the fall. The other thing that's happening is that ice does not freeze like it used to. And the same within the wetlands, the ice is different now. It's freezing different. The people used to be able to read the snow and the ice and know how to travel to get to their traditional hunting areas. They used to be able to tell what the weather was going to be, so we could travel safely out in the bay, but also within the wetlands during the winter seasons. We're having to adapt to these changes, and because of those changes, there has been lives that have been lost to the changes, because people have fallen through the ice into the water, and the weather can change pretty quickly when you're out on the bay in the summertime or the fall and traveling, and that's cost lives because of how weather can change real quickly. The other thing that's happening is rivers are starting to dry up in the summer times. In the summer months, people are unable to reach their traditional areas, where they would hunt in the fall for moose, and so they're unable to reach those areas because of the dryness, of the rivers. There's less and less water coming down those rivers in the fall. So what's happening is people are adapting by jumping on the train in Moosonee, heading south to Cochrane, and getting in their vehicles to have to drive around the boreal forest, within the southern region to hunt moose, because they can't no longer hunt in their homelands because of the impacts of climate change. The other thing is we have shortened seasons of winter roads because of early thaw. Winter rains are driving up the cost of living. People have to use helicopters to reach areas for food gathering. And at the same time, not everybody can afford that. So it's impacting on the food security of the people. Our people have been expressing the need to protect our region. We know that we contribute very little to climate change, but feel that we are most impacted as Indigenous peoples of the world. Impacts are coming from the industrialized world, mining, deforestation, oil and gas extraction, as you heard in the earlier presentations. We as a Mushkegowuk people are calling for assistance into protection of this significant region of the world our elders call the breathing lands of Mother Earth. In March 2020, we held a meeting and invited several NGOs and the philanthropic community to join us in taking action. We as Mushkegowuk people, along with our partners that have joined us since that meeting, March 2020, are speaking up, are speaking for the environment, the wildlife, the waters and water life. As they cannot speak for themselves, we have to stand together to speak for them. We are calling for the protection and conservation of a region that is important not only to us, but to the whole world for what it does in sequestering large amounts of carbon within its peatlands. We are calling on the governments to join us in taking action to conserve and protect. More recently, we have reached a milestone in conservation by signing a memorandum of understanding with Parks Canada, the federal government, to begin a feasibility study on the marine region of the Mushkegowuk territory, which covers approximately 91,000 square kilometers, and this will add to the 25% by 2025 and the 30 by 30 mandates the federal government has committed to. Now, what we have to do is we have to bring our attention and government's attention to wetlands region of our territory. And as part of taking action, what we have done to date is, we've done aquatic baseline studies of all the major rivers on the western side of James and Hudson Bay, and look to continue with monitoring that we've done that in the last 6 years. We are also working with World Wildlife Canada for mapping the carbon stocks of this region to add to the national map of carbon stores within Canada. We have begun a 3-phase program on climate adaptation, working with our elders and community people that's being funded by Northern Affairs Canada. We are proposing further studies on the wetlands, the peatland studies. There is a need for a wetland study to know its health and how it is being impacted by climate change, and to continue to monitor it. The wetlands, according to research, provide somewhere in the neighborhood of $700 billion per year in services. And that's regulating climate, recharging aquifers, absorbing and filtering contaminants, regulating river flow by absorbing and releasing excess water, providing habitat for waterfowl, fish, and other wildlife, storing and releasing greenhouse gases, nutrients, and contaminants, and maintaining soil resources and biological diversity. Threats to the region. Now, our previous Grand Chief and our recent Grand Chief have called on, the different impacts that could happen downstream from our region that's building in the western, just west of us, called the Ring of Fire. And we are not only downstream from this region, but we are down Muskeg, because there's streams that run underneath the wetlands, providing, that service to the rivers, but also into the James Bay. So everything from the Ring of Fire region to the James Bay is all downhill. And there's water everywhere, in terms of these wetlands. Our elders, have said that they've seen sea otters in inland lakes. And you wonder, well, how did these sea otters get from the bay to the inland lakes? And they said that they travel underneath the muskeg and these streams that eventually go to lakes and things like that. So the development, which are threats now to the region, include mining, road projects, as was mentioned, to open up the Ring of Fire region. And as you can see on this map, the red colored area is the Ring of Fire region, and there's roads that are going to be built from the Arrowland First Nation north to Martin Falls. And there's a supply road that's coming from the Webequie First Nation to the Ring of Fire region. And there's going to be a third Northern Link Road, is what they're calling it, that'll connect the Ring of Fire to Martin Falls, thus providing the infrastructure for a road corridor right down to the Highway 11 route. That, this is what these companies are waiting for to happen. But if you look at this map, you can see that the Ring of Fire is almost in the middle of the Hudson Bay Lowlands, in this carbon-rich region. And it's a huge area that will be impacted, when the work begins. There's said to be just over 17,000 claims in this region. And there's a potential of huge area of peatland loss and potential of downstream impacts that'll impact the whole region and into the James Bay. Said to be 150 to 200 years of mining in this region. At one point, they did say that you could see a city the size of Sudbury, which is 150,000 people in this region in the future. So any disturbance to this region, will impact on its ability to sequester the carbon and could become an emitter of greenhouse gases at a large scale. The federal government has called on a regional assessment for the Ring of Fire project. And we've asked, we have a call to be included in this process, but to no avail. So all the things that we've asked for in terms of co-governance, being recognized nation to nation, is being refused. The regional assessment is proposing to have a committee of people that are non-biased, neutral, that will hear our concerns. But again, we find ourselves on the other side of the table, having to express our concerns, and there's no guarantee that they will listen to what our concerns are. That's been our past experience, And the same goes with these road projects. We put in our comments to the terms of reference for these road projects, and again, largely being ignored. ignored. We've called for a moratorium, on the road projects. Let the regional assessment go forward before the road projects. Put a moratorium in the region because we need to look at the wetlands. We need to know, what the potential cumulative impacts could be in our region. And I remember asking experts, if this ring of fire in our wetlands region and the second largest carbon sink in the world could coexist. And those experts told me, we don't know. So, that's why we need to do some work and, look at this region and begin to look at how we can put a proper protection, and conservation plan together before anything should happen to the west of us. And again, we need to reconcile our relationship with the lands and waters throughout the world. We need to do that. Thank you. Thank you very much. Miigwech. So I'll hand it back to our moderator.
Thank you so much to all the speakers. Thank you, Vern and Justina and Lorna, for sharing all your knowledge. And so now we're going to open the floor to the discussion questions that have been coming in throughout the presentation. And so I will read out the question, and then, as appropriate, the speakers can answer these questions from the audience. So one of the first questions that came in, and one of the most popular questions, is just what policies are in place in Canada right now to protect peatlands? And so I would suggest that Justina is probably the best person to address this.
Yeah, thank you very much for that question. I mean, as I was framing the presentation, the part of the presentation that I delivered, I really tried to focus mostly on the gaps, and there are many. And that's why there are such significant work ahead in terms of not only globally to bring peatlands into the framework more deliberately, and to consider them now that we understand the impacts much more clearly and are doing so increasingly. But in Canada, absolutely, they're not considered other than restoring for the most part, or if they're involved in the context of project level impact assessments, as we've talked about, but none of it is adequate, and neither is the accounting. And the protection is also inadequate in terms of that there's only about 10% of the peatland extent is currently under protection. So that's why there is so much work ahead of us. Thank you.
Maybe if I can add to that, if you don't mind. Ontario's policies, is they've made a move to what they call removing roadblocks from legislation, to provide for development to go forward. They've relaxed their environmental assessment process. They've forestry companies, are now exempt from environmental assessments of the forest management units that they work in. Bill 197, has watered down the environmental assessment process to allow for for development to go forward. As I mentioned, our First Nations are challenging those changes that have taken place, and the Far North Act, when the government has pulled it back, for review, and they said they've completed it, but again, their language in the Far North Act is to remove roadblocks. And the latest, from the Ministry of Northern Development Mines is the critical mineral strategy, which is being promoted, and again, it's the same language that, removing roadblocks for development to go forward. So it's just a different way in how to spin it, I guess, and trying to get, you know, at these minerals that are in that northern region. That's all I wanted to add. Thank you.
Thanks, Vern. The next question is probably best answered by Vern, but it is, are there communities involved in monitoring peatland fires, especially in the far north? First Nations people have incredible knowledge, records, and historical understanding. How are decision makers able to access this type of knowledge? Was the question from the audience.
Right, thank you for that question. At the present time, you know, we've worked with the Ministry of Natural Resources over the years to, you know, to respond to these fires that happen within these regions. And in large part, you know, we've wanted these regions, you know, when fire happens to be controlled, because to the ministry, you know, it's a vast area of emptiness, you know, and when fire starts, they let them burn, you know, they let them burn. And we did you know, we did some meetings within our communities, you know, in trying to revamp the far north, you know, forest fire practices of the Ministry of Natural Resources. And what came forward in the communities is the number of losses that people experienced because of forest fires, the loss of camps, the loss of, you know, their tools, their hunting tools, and things like that. You know, it was a lot of loss, you know, that took place then. And that we said, you know, we need small teams of people to go in as soon as a fire starts, you know, to get at it and to put these fires out, because there's a huge loss. What you see as emptiness, we told them, is that there is a network of people that live in these regions that use this area to hunt, fish, and trap, or, you know, gathering food and things like that. So that's, you know, that's what came out of it. And so from what I understand, you know, the forest fires that are allowed to burn are still happening. Not a lot has changed. And it's not until a fire comes within 15 kilometers of a community when they take action to remove people. So.
Thank you, Vern.
Yeah, thank you.
So the next question is about cumulative effects, but it says that it appears that cumulative effects policy and tools can be used to help inform development and conservation decisions. Have there been any efforts to understand cumulative effects? So perhaps between Lorna and Justina, you can address this question.
Well, I'll just say that most cumulative effects frameworks in Canada and elsewhere do a pretty good job of forecasting cumulative effects, looking at various scenarios, but they tend to be science products that sort of sit on the shelf and don't actually inform or provide direction to project level, you know, decision making that happens afterwards. In the context of the Ring of Fire and the peatlands that we're talking about here, you know, there are many information gaps related to cumulative effects that, you know, but there we could do much better than we are at present if we had the right processes in place. The regional assessment that Vern mentioned, that I mentioned, of the Ring of Fire, which is meant to be sort of an advanced look at the region, what are potential impacts. It was put in place by the minister, the federal minister at the time, a lot for the purposes of preventing cumulative impacts, knowing that that could occur with time if the pace and scale of development was not well considered, well planned, well executed. And because, and at that time, that was why the regional assessment was put into place. To date, there's been no concerted attention to cumulative effects, just sort of talk about it, a little bit of discussion at the project level with these various road planning exercises that are occurring. But we have yet to see a process that would help really specifically inform the pace and scale of development, perhaps place a limit on the number of mines, look at alternative routes for roads for various purposes in this very sensitive area. Lorna, you might have some things to add to that.
Just thinking about this landscape, and what I talked about earlier, the landscape scale hydrology, the upstream impacts, those downstream impacts, and we heard about the importance of the shoreline of James Bay, Hudson Bay, for migratory birds, for other wildlife. This region, we have to consider cumulative impacts. It's just not something that we can't do. It's absolutely essential. Anything that happens upstream is going to affect something downstream within this landscape, and especially when we're talking about a development on the scale of the Ring of Fire. Yeah.
Thank you, Justina and Lorna. The next question is, can the mining of different minerals in the Ring of Fire be done underground without doing an open pit mine or creating a large area of underground dewatering? And so I'm not sure, Lorna, would you like to take this one?
I can, from my understanding, is that most of it is planned to be open pit mining, and I'm assuming that is because it is the most cost-effective means of extracting the minerals. I don't know if there is a technicality there that underground mining is just not feasible within this area. One of the other things in terms of the developments within this area is the impact of the roads. They are proposing what I think are floating roads, but across this landscape, and you've seen how wet this landscape is, how connected this landscape is with the patterned fens, the water tracks. Floating roads are used a lot in Scotland, but these are drier peatlands. This landscape, the Hudson Bay Lowlands, when we talk about flown roads, the engineering, I think, is going to be a little different within this region. I think in terms of mineral extraction and impacts to peatlands here, it's not just a small area of peatland, the whole area is peatland. You've got no choice but to deal with the peatlands. And I think that's what engineers, if they're proposing development here, really have to consider. Are there other methods of mining? Is underground mining possible? Even if it is more expensive, are other road engineering mechanisms possible? Such as above ground, above like a causeway above the peatlands to minimize disturbance, to minimize changes to the hydrology. I'm not sure if there are options there. Maybe Justina has more to add on the below ground aspect.
Yeah, so first of all, I do think that the point about the fact that you can't think about mines in isolation, you have to think about them in concert with the infrastructure that they bring. And so the roads are really very, very central to this whole question because they have multiple purposes. They don't only, provide access to these mineral deposits, but they're also very important for community access because quite a lot of these communities have been relying on winter roads, and the life of those winter roads is diminishing every year. Back to the mines, it does depend on the type of ore being extracted. There has really only been a couple of designs so far. One big chromite mine, which was open pit, that did not come to fruition. There are future interests in chromite mining that may occur, once the road is built. Currently, there's a proposal for a nickel mine that is underground, and it has been redesigned to be like that, a smaller footprint in that way. But the question is whether or not, especially when you kind of accumulate these different types of mines that make it more possible to exploit other ores in the area, what that would look like from a cumulative basis together with the infrastructure.
If I could add to that, the other thing is, it's right now it's a computer model, right? But we don't know in reality how that's going to work because it's such a vast land of water and muskeg and how we don't know how that's going to happen, right? I know that they plan to use cement and things like that, cement the tailings within the mine, but we don't know what could happen, right? And so that's why we need to look at what are the possible cumulative impacts that could take place in the south, downstream from it. And and like you mentioned, there's very little information available for that, and that's why we need to do more studies and to learn more about what is downstream and how important that region is. But I'll also say that I've always said that we're not against development, but we need to be smart in what we're going to do. We don't want to stop the First Nations from developing their communities with these road projects, but we need to look at proper plans in terms of how these things might impact on the wetlands in that important region. So yeah, that's one. Thank you.
Thank you, Vern and Justina and Lorna. We are almost at the end of our time. I think we have time for just one more question very quickly. But one person said this is very sobering. So what can the international community do to encourage balanced planning for this area of Indigenous Canada? So maybe each speaker can go and sort of give their 30 seconds of what do you think the take home is from this international audience of what you want people to take away and do after this presentation. So we'll start with Vern and then Justina and then Lorna.
I forgot to unmute myself, but thank you very much. As I mentioned in my presentation, the call, for everyone, throughout the world to help us in, bringing attention to this region for its importance and what it does not only for us but for the whole world. So we're calling, on everybody to help us. Write letters. I'm not sure, but we need that help. To along with the people that we're working with now, like Wildlife Conservation Society, the folks you see here, and the other NGOs that have joined us, and the philanthropic community that have joined us, because they believe in this work and what we're doing to try and conserve this region and protect it from disturbance so that it can continue to do what it does naturally. And that's my 30 seconds.
And I'll just say that this provides a great case for proactive protection, conservation of intact forests and peatlands. Do not wait until the project is immediately threatening, but thinking about this in a proactive sort of long-term carbon management perspective.
Yeah, so we've heard a lot about intact forests over this climate summit. We've heard a lot about other ecosystems. We've heard a lot about peatlands. Great to see peatlands in the spotlight at this event with so many fantastic talks. We did have the Canadian government make a big announcement that Justina mentioned over the weekend in terms of a large amount of funding for nature-based solutions. And I'm really hoping that the Hudson Bay Lowland is right up there in the forefront of the government's mind, alongside, of equal value to other global peatland hotspots, such as the Congo, such as Southeast Asia, and Indonesia, and the Amazon as well. So the Hudson Bay Lowland is Canada's Amazon rainforest, basically. It's hugely important for the world, and I really hope the Canadian government can see that and recognize that.
Okay, so I will just say thank you so much, Miigwech, to the three speakers, to Justina, to Vern, to Lorna, for sharing all of this knowledge. Thank you to everyone for asking questions. And if you want to learn more about this work, We do have a new story map. We'll put the link in the chat and in the notes and sort of everywhere on Twitter so that you can find the information and learn more about the, as I mentioned in the chat earlier, you can see the policy brief. The paper that Lorna mentioned will be available November 15th, and it will also be linked from the story map. And so also just, thank you to you. Thank you for tuning in, listening to us, spending your afternoon or your evening with us, depending on what time zone you're in. And yeah, thank you again. We're very grateful to be here.